back on Thursday, we learned how to factor all types of polynomial functions. So we no longer need to do polynomial functions in order to factor them. Today, we're just going to take it one step further, and we're going to solve polynomial equations. Okay? So the only difference is on Thursday, we wrote them as a product of its factors. We factored it and wrote it down bracket times bracket times bracket. What we're doing today when we solve it is we're taking those brackets and setting them equal to 0 at the end. So again, remember, it's very important on answering which question is being asked, right? If it's asking you to factor, just leave it in the bracket form. If it's asking you to solve, solve the equation at the end. Two different things. Okay? Make sure you're answering the question correctly. So this is a polynomial function. It's a cubic. The only way I can factor a cubic is by grouping, right? This doesn't factor by grouping, so now we use the factor theorem and the whole long division, synthetic division that we learned. So I need to guess a binomial that will go into that polynomial. And when I'm guessing, what numbers do I want to use again? Somebody remind me which ones, John? Correct. You want to guess factors of the constant term. Okay? So you would guess, again, remember though, I said you can skip a step if you like synthetic division by just writing down your synthetic division, remembering to put a 0 placeholder in for every term that isn't there. That's one of the most common mistakes on a test. People forget to put in that 0 placeholder. Okay? And then you just start to guess factors of 2. So, or guess -1. So if I'm using -1 here, what am I dividing by? Remember, I'm dividing by a binomial, right? This is a quick way of doing long division. X plus 1. Right, so that's what I'm dividing by. So if you don't like synthetic division, what you would be doing is taking x plus 1 and dividing it in here using long division. Okay? Bring the 1 down. That would be a positive 1. Sorry. Adds to 2, multiply -2, I get a 0 remainder. Okay, so now I did get my 0 remainder, so x plus 1 is a factor. So I'm going to write down the right-hand side of the division statement. My divisor was x plus 1 because I used -1 as my a factor, and then I'm left with the quotient. And I'm still have an equation, so I have to write equals to 0. If you don't, you will lose marks. So now what I do is I factor that quadratic. Okay? So that I factor the quadratic so I can put it into its 2 brackets, and then I set each one of those 3 brackets equal to 0. Unfortunately, this quadratic doesn't factor. Right? So if it doesn't factor, what do you do? Nick? Right. So I'm just going to write down what we're doing here. So I'm setting each one of these equal to 0. My first answer is x minus 1. My second answer and my third answer come from the quadratic formula. X is equal to -b plus or minus b squared minus 4 times ac all over 2a. So I did a lot of math there, substitution without showing any work. Simplifying, I get x is equal to 1 plus or minus I root 7 over 2. So those are my 3 answers. My first answer is x equal to -1, and my second answer is equal to 1 plus I root 7 over 2, and my third one is 1 minus I root 7 over 2. Any questions on that? Okay. Let's try this. So this one is really what I was talking about on Thursday. And I told you you had to wait the whole entire weekend for me to show you how to guess those fractional answers. I'm sure with the Dolphins winning, they'll make her sleep a little bit better. Okay, so if we guess factors of 2 here, so -1 and 1 and -2 and 2, and do this all the synthetic division, you're going to find that none of them work. Okay, but there are answers to the question. So how do I get those answers? Those answers come from something called the rational zero test. So what this does, rational means fractions, right? Positive and negative. So this gives you all the possible answers that are in fraction form. Please don't talk while I'm teaching. Okay, so the rational zero test says in a polynomial, p of x, so the leading term of a polynomial has the leading coefficient x to the n, and then the coefficient a to the n in front, and then it heads all the way down to the constant term. So that's just a polynomial in general, and these coefficients have to be integers to use the rational zero test, which just means they're positive and negative whole numbers. Then, if that's the case, every rational zero, and all that rational zero is a fancy word for saying all the fractional answers, bless you, of p of x is of the form p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. So keep in mind what this test does is it gives me all the possible answers. So going back to this original question, I saved the list a little bit of step. Usually what I would do is give the class like a couple minutes to figure out which number worked, and nobody would be able to find it. Okay? So then what this does is this gives me all the possible answers that would work. So this right here is my leading coefficient. This right here is my constant term. So my p's are factors of my constant term. All the numbers that go into 2. So plus and minus 1, plus and minus 2. Those are all the numbers that go into 2. And my q's are all the numbers that go into my leading coefficient, which is 12. So plus and minus 1 goes into 12, 2, 3, 4, 6, and 12. Then if I want to get all the possible answers, I just take all of my p's and I divide them by all my q's. So I'm going to start with plus and minus 1. Plus and minus 1 divided by plus and minus 1 is plus and minus 1. Plus and minus 1, I'm not going to say that every time because it works out. So 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 4 is 1/4. 1 divided by 6 is 1/6. 1 divided by 12 is 1/12. So those are all the answers when I take 1 and divide it by all these numbers. Now I'm going to move on to the next one, which is 2. 2 divided by 1 is 2. 2 divided by 2 is 1. That one's already accounted for. 2 divided by 3 is 2/3. 2 divided by 4 is 1/2. That one's already there, and I'll have to rewrite it. 2 divided by 6 is 1/3. That's already there. And 2 divided by 12 is 1/6. I don't need to rewrite that one. Any questions? So 1, 2, 3, 4, 5, 6, 7, 8 times it by 2 because of plus and minus. There's 16 answers. So 3 of these are going to work. Okay, so what I said at the beginning, if we use plus or minus 1 and plus or minus 2, that wasn't going to work. So that means this fraction set, or these fractions, one of them are going to have to work, and you would just have to try them. Okay. So we'll try 1/2. 12, 8, -3, -2. Okay, so I'm using synthetic division. So when I used 1/2 as my a value, what binomial was I dividing through by? Yeah? Okay. No, because remember it has to be in standard form. That's enough to write that, right? Rebecca? Close. 2x minus, right? Okay, so this right here represents that binomial. Okay, because if I solve for my a value, remember what we did is we factored out that 2, and I ended up with 2 bracket x minus 1/2, and that's how I use that value. Okay. What did I need to do when I used synthetic division and I factored out a number? What did I have to do with the quotient? Does everybody remember? Remember, if I originally said take this polynomial and divide it by this, then we would have had to factor out, and we ended up with that, and we used that value right there, and then all my answers were opposite. Divide by 2, because everything's going to be 2 times bigger. So we had to divide everything by 2. So that's the trick about using synthetic division. So this really is 6, 7, and 2. Okay, so 2x plus 1 is my, and again, if you write down x plus, or x minus 1/2, you will lose marks. It's on standard form. Okay, so 2x minus 1 represents that 1/2, and then I'm left with the quotient of 6x plus 6x squared plus 7x plus 2. I look to see if I can factor that, and that is factorable using a hard type trinomial, and that factors to 2x plus 1, 3x plus 2. And then you solve each one of your factors equal to 0. And those are the 3 answers. So you can see 1/2, -1/2, and -2/3 were all answers here. So plus or minus 1/2 and -2/3. So on a test, will I give you a question like this? Absolutely not. Okay, because I don't want for you to be sitting there and guessing all those fractional answers. A question where you'd want to use this would be something like, I'll give you this equation. I'm going to say list all the possible answers. And that you have to do that. Okay? So I don't want you guessing the entire text. Any questions on this? Okay. One last example. Okay, so this question reads, the equation 3x cubed plus 25x squared minus 48x plus 20 is equal to 0. It has roots of 1, h, and k. Okay, so when it says it has roots of 1, h, and k, what does roots mean again in math? What are the roots of a function, Rebecca? Yeah, the x-intercepts are the x, the answer. Okay? So that means if I solve this equation here, I'm going to get 1 as an answer, and I don't know the other two, so I call them h and k. Okay? I want to determine a quadratic equation whose answers are h plus k and h times k. What do you think I should do? Yeah. Why? Well, that gives me something to start with, right? Perfect. So let's do exactly what John said, which is to factor this so that I can solve for the other two answers. Okay, now it's guessing time. Which number am I going to guess, Rebecca? Close. Right. I don't need to guess because it told me 1 is already the answer. Okay? So I know 1's going to work. So I put 1 out there. So I took this equation, I divided it using 1. If I used 1 as my a value, what was I dividing by? Yep. Right. X minus 1. And I'm left with my quotient. I factor this. You look for two numbers that multiply to give you negative 60 and add to give 28. So you can find those two numbers. So it's a hard type trinomial. You factor it. That times that is negative 30. So I have these opposite. So again, that's what you should always do when you're factoring. It's just multiply it out in your head and make sure you've done it correctly. So that times that is that. That times that is positive 30. That times that is negative 2. That gives me that. That times that is negative 4. So now I solve for my answers. Those are my three answers. I already knew 1. Now I have 2 over 3 and negative 10. Which one's h, which one's k? Yep. Doesn't matter. I'm going to call this one h. I'm going to call that one k. Now, in this particular example, it doesn't matter which one's h and k, because if I take h and k and add them, I'm going to get the exact same answer even if I take k and add it to h, right? Because the order doesn't matter when you're adding, and order doesn't matter if you're multiplying. But if this was h minus k, then I would get two different answers if I took 2 over 3 minus 10, if I took negative 10 minus 2 over 3. And if that's the case, you'd have to do two cases. You'd have to do case 1, h is going to be this number, k is going to be that number, and then case 2, do it all over again, where k is this number and h is that number. Make sense? Okay, so I want to come up with a quadratic equation whose answers are h plus k and h times k. So I want the answers to my equation I'm looking for to be equal to h plus k and h times k. So let's figure out what those answers would be. So that would be 2 over 3 minus 10. Find a common denominator. So my first answer, I want to be negative 28 over 3. And my second answer, I want to be negative 20 over 3. So those are the answers I want to the equation I'm looking for. So if those are the answers, if x is equal to negative 28 over 3 is my answer, what factor would I have solved equal to 0 to get this as an answer? So what expression would I have solved to get that as an answer? John. Put it in standard form. Remember, always want it in standard form, right? Awesome. Okay. So if I solve this, 3x plus 28, the negative comes to, excuse me, the positive comes to the other side, becomes a negative, divide by 3, I get that answer. Does that make sense? So what would the other one be? So this one here would be 3x plus 20. So here's my first factor. Here's my second factor. To make it into a quadratic, I multiply those two factors. Multiplying, expanding everything out, and you would get 9x squared plus 144x plus 560 is equal to 0. So this is a quadratic. If you factored this quadratic, it would factor to that. You solve the factors, you would get that as an answer, you'd get that as an answer. And that's the quadratic equation whose answers are h plus 1. Make sense? Okay. So I'm going to save